depending on the satellite, sometimes a higher resolution image is collected with monochromatic or grayscale than is with color. And one example of that is SPOT. So the French satellite SPOT collects 10-meter resolution grayscale, and then for the color imagery, it collects that at 30 meters of resolution. So if we want to have a color image that takes advantage of the high resolution that we're seeing in the grayscale, we can do this IHS transformation. So IHS stands for intensity, hue, saturation, and it's just a way of representing colors in a display. Of course, when the imagery is collected, it's collected at RGB imagery, right? It's collected by measuring part of the electromagnetic spectrum associated with red and green and blue. So those would be the three bands that we're talking about. But we want to do a transformation so that we can represent that RGB imagery in the IHS color space. So here would be the steps involved. First, we would convert the color imagery from RGB to IHS. That would be the 30-meter spot, for example. Then the I represents the intensity or the grayscale of that imagery. We can remove the grayscale from the color imagery, and then we can take this grayscale imagery that was collected at a higher resolution, such as the 10-meter spot imagery, and we can substitute that in for the I portion of this color model, and we can get something that is a higher resolution image than what we had with the 30-meter color imagery. It's a combination of 10-meter grayscale imagery and 30-meter color imagery. So remember, in the RGB color space, right, this is how the data is collected, and 3 different bands, and we can display all of these different colors as some combination of red and green and blue. In fact, there's 16.77 million different colors we can represent that way. But this is just one sort of color space. This is another sort of color space called the IHS. So in this, it's similar to the, we have the color circle, where all of the colors of the rainbow are represented around the edge here. And then the S, or saturation, is represented by how it varies from white in the middle of the circle to the pure color out by the edge of this circle. So similar to the HSV color space, except the IHS, the other part of it is the intensity, which is varying from white to black as we go towards the bottom of this cone here. So once again, a different way of thinking about colors, but we're able to represent all the colors that we can represent in the RGB color space with this other color model. So here's what we do. We start out with a fairly low resolution like this 30 by 30 meter spot imagery here, and we can make out some indications of here's a road with on-ramps and off-ramps here, but we can see that the 10-meter resolution is much sharper. We're able to see a lot more detail here than we can see in this imagery here. So we take the color from here, we convert it into the IHS color space. We use the intensity, we use the hue and saturation from the color, and we use the intensity from the more detailed monochromatic representation that we got from the spot imagery, and then we combine it into this image over here, which is much higher resolution than what we started with because we're introducing 10-meter imagery in here, but the colors match and everything looks the same as what we would expect it to in this false color remote sensing image.